Right. All right, thanks for coming on into Domestic Hot Water Part 3, our all-electric design and construction series. We have Jennifer and Grant from Imbalance Green Consulting with us today to teach you guys and answer questions. And before I hand it off to them to start today's training, I have a few administrative things to go over. Great, thank you. All right, a few Zoom reminders before we get started. Please remember to keep yourself on mute for the duration of the training. If you have any questions, and we definitely encourage you asking questions if anything comes up, you can either add it to the chat and someone will be able to answer for you in chat, or you can raise your hand and we can invite you to unmute yourself and answer or ask your question out loud. The session today is being recorded. The slides and recording will be distributed with you in the next few days. We will be using Zoom attendance to distribute our ZNCD and AIA learning units. So if you want to receive these learning units, please make sure that you have registered for this event and provided your AIA number, and that you're joining today from the Zoom link sent to your email after registering for the event. If you're joining from someone else's Zoom link, calling into today's training, or viewing this presentation on a shared screen, your attendance is not going to be recorded correctly. So if you think that you might fall into one of those categories, please email me to make sure that you get credit for attendance today and that you get the correct learning units. I'll be adding my email to the chat within a few minutes. My email is also going to be in the slides from today's presentation. So the AIA learning units and ZNCD certificates were distributed for part 1 and 2 of this training. If you didn't receive them, please email me and I can look into it. I know many of you tuned in for part 1 and 2 of this training and have seen this slide before, but for anyone joining us for the first time today, I will quickly share a bit about who we are. We are the Tri-County Regional Energy Network, aka 3C-REN. 3C-REN is funded by ratepayer dollars that we all pay into in our utility bills through the public goods charge. The benefit of being ratepayer funded is that there is no cost to those we serve. And as a regional energy network, we are able to return these ratepayer dollars back to our local economy, which has historically missed out on many of these funds. We can go to the next slide. Thank you. 3C-REN currently offers 6 programs focused around 3 services. These include incentives, training, and technical assistance. This training series that we're all attending today is part of our Building Performance Training Program. You can see additional trainings being offered and learn more about our other services by visiting our website, 3c-ren.org. I'm ready for the next slide. Thank you. Since 2019, 3C-REN has had over 4,000 individuals attend trainings, answered 334 Title 24 and Cal Green questions, secured $155 million for investment in the Tri-County region, and completed 1,374 energy-saving projects. And we are all very excited to be continuing to grow in all of these areas in 2025. And with that, I will hand it over to Jennifer and Grant to start today's training.
You. Welcome, everyone. This course that we're doing does qualify for the zero net carbon design credits needed for California Architecture License Board. Also, you can get AIA learning units for it. And this is number 3 in a 5-part series, and each one of these is worth 1 hour or 1 credit, and you will get a copy of the slides later on for your reference. Today, Grant and I are going to go through heat pumps for hot water, so domestic hot water. But really, we're specifically looking at heat pump technology as part of California's movement towards all-electric construction. A lot of you maybe already know I'm a licensed architect and a certified energy analyst with Imbalance Green Consulting. Grant is also a certified energy analyst also with Imbalance Green Consulting, and we, work closely with 3C Ren to provide education and outreach, and we are code coaches. So we'll plug the code coach at the end of the slide deck, but just a reminder, like Chloe said, you can contact us, you can reach out to us and get your code coach questions answered for free, and that's open to architects, builders, plans examiners, and the general public. California is on a pathway for clean energy, and there are a lot of clean energy goals that California has as a whole as we move towards net zero carbon design. So California is making a clean energy transition, and they are working, all of us are working together for a carbon-free electric grid where the buildings are increasingly decarbonized. And today we're specifically going to be talking about some of the operational energy use, hot water, as a way to decarbonize our buildings. California is also working with the industrial sector and trying to improve how our industrial sector is powered by clean electricity and clean fuels such as green hydrogen, where electricity may not be the best source of energy. And we're constantly looking at transportation choices that are zero emissions or at least hybrid electric. And I just heard from our governor that California has about 25% of its automobile and transportation sector already on that path for the decarbonization and low emitting vehicles. So big picture goals for the 2022 Energy Code and the 2025 Energy Code update is to continue encouraging heat pump technology for space heating and water heating, establish electric ready requirements for the single family homes, but also that's expanding into multifamily and non-residential, and expanding the PV system and battery storage standards across all types of occupancies, and strengthening our indoor air quality ventilation standards along with that. And mainly the big reason behind this is because homes and businesses use nearly 70% of California's electricity and are responsible for about a quarter of California's greenhouse gas emissions. So the building sector is definitely a place where all of us as designers and building professionals can make a difference in moving California towards a carbon reduction in how we operate and construct our buildings. With that said, refrigerants that are used in our heat pump technology for space heating and water heating also contribute to GWP or global warming potential. And a lot of our heat pumps currently use R410A refrigerant. Put that in perspective, that has a global warming potential of 2088. That is reduced greatly from some of the refrigerants that used to be used, which are many times higher than that. However, with the American Innovation and Manufacturing, or AIM Act, there is a call for phasing out refrigerants with high global warming potential. And I noticed the international body that looks at global warming potential has now, and California's following suit, they're starting to say that anything over 150 global warming potential, GWP, is considered high GWP refrigerant. So the EPA, for now, under the AIM Act, has set a limit of 700 GWP for chillers, air conditioner, heat pumps manufactured after January 2025, which is now. So the phase down is beginning. So some of the heat pump water heaters are moving to refrigerant R5 513A with a global warming potential of 630. However, you can get heat pump water heaters that use even lower global warming potential refrigerants, such as CO2. It has a global warming potential of 1. And I was just reading this week that Carrier US is making a heat pump system that can work both for space heating and domestic hot water that's using propane, and that has a global warming potential of less than 1. And that equipment is currently being made available in the UK, and soon it should make its way to the US. But we'll talk a little bit more. We'll touch on a little bit more on heat pumps that can both heat your hot water and help potentially condition the space for your space cooling and space heating. And then the other refrigerant that's showing up in those types of systems that could do both heating for space and hot water is R32. And that does meet that 700 global warming threshold. And you'll see some of the product lines kind of advertise some of these things as we do this phase down to show that the products are meeting the new requirements. So with that, we're going to get into the heat pumps for water heating and the types and where they can be used. So kind of big picture, single family dwellings, commercial applications, there are large systems that can be used in industrial applications, or very large central systems for like hospitality and multifamily. New construction is fairly straightforward, but we're also seeing a lot of these systems being used as replacements and in your retrofits or alterations, where you might have an existing water heater tank style that is electric or gas tank, and then these heat pump systems can replace those and provide energy savings to the customer. This gives you an idea of what that is going to look like. So the picture on the left, single family, it's called an integrated system. It's got the tank on the bottom, the heat pump on top. We'll diagram that out in the next couple of slides. And there's also split systems where the system that does the heating and cooling, in this case for domestic hot water, it's on the outside, which is providing the heating. It looks like a condenser unit, just like for your space heating and space cooling, only these outdoor condenser units are providing heat that goes into water storage tanks. And a lot of times the tanks are located indoors, but they can be located outdoors, like this project that's in Santa Barbara County. And there's a even larger storage tank that is inside the building that keeps that water from cooling off too much. We can also take those split systems and group them together. And there's a company that you'll probably see more and more of. They're branding it as the Water Drop, but they're taking the Sandon heat pump split system and putting it into small containers that can be lifted and placed on a building. And it includes your storage tank, your buffer tank, your control system, and then the outdoor units are all mounted all together in one clean package. For very large systems, Rheem is now, and there's a few other brands now that are starting to provide large heat pump water heaters, and oftentimes they'll recommend that you put the storage tanks for the water inside the building, but the large heat pumps can be located on the roof of a multifamily or hospitality or even an office building, depending on the hot water needs. For combined systems, this often is referred to in the smaller scale like a monoblock is how it's often branded or talked about. And LG has a system that is available where you can capture the heat from your variable refrigerant flow cooling system, put that through a heat recovery and a distribution block, and then hot water pipes can provide space heating and the domestic hot water, but you can use those variable refrigerant flow units directly for cooling. And they also offer a system for residential where they have a dedicated air to water system outdoors, and then that provides the hot water for space heating and cooling. And in a lot of cases, this is eliminating the need for an indoor boiler or gas heater for most climates. If you are in a cooling climate, however, there are systems like SpacePack now is offering their monoblock, where they're also including a small ducted high velocity system. Small ducts provide the cooling. So when you're in cooling mode, the outdoor condensing unit will provide the cold water that runs through a fan coil. So you get your air conditioning, but they can also then in heating mode, run the hot water into your either radiant floor system or a wall, high wall or baseboard system to provide the heat. And a lot of these monoblock systems are moving towards the R32 refrigerant. So global warming potential unit. And in this case, they're using like the Mitsubishi inverter for a high performance. And the other type of system out there now, there's a lot of new stuff that's coming out. So one brand, Harvest Thermal, they're making a controller where they use the Sanco 2 split system, similar idea to what we looked at, but their controller works specifically with the Sanden product, and they'll use that controller to send hot water to the fixtures or send that hot water to a ducted air handler. And we're learning more about this project as Andy, who's in our office, is living with this project, and it's her house. And I think she's on the call. You might be able to ask her some questions in the chat about that. Okay, there's Andy. She turned her camera on. Say hi. But this is her house, and we're happy to learn more about it. Is there anything you want to say about that, Andy? Well, since you're on.
No, just, I mean, from a personal choice, I was really supportive of this system because it does use a Sanden, which does have that super low global warming potential. It's a really big tank. It's 120 gallon, and it heats it hot. We've never had a trouble with running out of water. But it has, you know, our house is not super insulated, so it's not as quick to respond like it was under the furnace. So that's been a little bit of a learning curve, but the system itself has worked great.
Okay. Oh, that's good. Thank you. And then for really cold climates, there's some folks doing some innovative things where they're creating the outdoor evaporator coil. They're exposing it, painting it black, and you put it in the sun on the south exposure on purpose, and it's giving the system a solar assist. And they have their smart solar controller system that also then heats your hot water using some of the passive solar aspects as well as the heat pump technology. that we were looking at with these other units. And then last but not least, for kind of the new things we're seeing and sort of the entrepreneur creative folks out there, is this company is now taking the LG heat pump water heater and combining it with their controller and solar PVs, and basically using the tank as a thermal battery. And so really coordinating when when the sun is shining, they can heat the hot water, and it's cooperating with the heat pump mechanism that's integral to the tank. And it allows for a lot less electricity use, and also just basically use it when the sun is shining. Okay, we're going to take, that was kind of the high level overview of all those technologies. But right now, I want to take you into a little bit closer look at the heat pump water heaters for the consumer. And this is, it's mostly, we're talking single family scale, ADU scale, or individual heat pump water heaters for apartment buildings. You can do central systems with the other equipment we showed. It does mean that you're going to be usually, working with a mechanical engineer. But as architects, a lot of times it may fall to you to understand all the sort of pros and cons and what's going on with heat pump water heaters when you have it on a single family or an individual apartment dwelling scale, and small commercial for that matter. Now, the market and kind of the brands available is changing rapidly. So the last time we did this course, it was just a couple months ago, and there were only about 22, 21 brands available under Energy Star. But I double checked this yesterday, and now we've got 31 brands available under Energy Star. And if they're under Energy Star, they do qualify for certain rebates and tax credits. And it is a good way to familiarize yourself with what's available if you're not that familiar with the market on heat pump water heaters. And you're going to get a copy of the slides, so you'll have some reference and links to some of these websites. Now, in the US, there are a lot of brands, and in our area, these are the ones that are most readily available, is what we're seeing. And a lot of these brands actually are kind of made by the same manufacturer. So A.O. Smith, for example, makes the Lochnavar and the State system. Rheem is also Rudd. So sometimes it's marketed a little different based on the part of the country you're in, or our country you're in. But other times it's because they'll have a brand that's slightly different, maybe billed as the lower cost or the builder's version, and then they've got the higher end version. So parent company Rheem makes Frederick, Rheem, Richmond, Rudd, for example, and A.O. Smith, American Water Heaters, Lochnavar, Reliance, and State Water Heaters. So the two parent companies, Rheem and A.O. Smith, are readily available in our area. And most of these products can be ordered online. However, you can also find, like, Home Depot has the Rheem product line. You go to your Lowe's and they're going to have the A.O. Smith product line. If you go to Ferguson's, you're going to see A.O. Smith, but also the State version, and Bradford Wright and Rheem. And then through installing contractors, you can get access to, like, the LG units and many of the other brands that are out there. Kind of a little review, because I showed you some pictures, but just to clarify, that when you're talking about the heat pump water heaters for domestic hot water heating, they're all air source. The integrated type that has the tank on the bottom and the heat pump on top, it's a unitary system, sometimes called unitary, sometimes called integrated. It's often referred to as hybrid because it has electric heat pump and electric resistance. But just a word of caution, when you go online and you start looking up different products, you will also see gas water heaters being billed as quote unquote hybrid because they've got gas and electric resistance. So that word is used kind of loosely. So just be clear that there's no gas involved with the heat pump water heaters, no natural gas. And then the air source split system, meaning you've got the outdoor condensing unit outside and a tank inside. And what that looks like is the heat pumps on top, typically large storage tank below, and on a lot of the older systems, the air comes in at the top and it is pulled through the heat pump system and a fan blows it out, usually the side. There's electrical connection, but there's no gas connection and no flue. And they do make a plug-in version now of that. And we'll talk a little bit more about that coming up. And then identifying your split heat pump water heater system. You know, in the name, it's split. There's no heat pump on top. You still have your large storage tank, outdoor units, outdoor. And again, no gas connection. So you don't have to worry about that infrastructure or flues. Now, I'm going to go into a little bit more detail on the integrated heat pump water heaters and what to kind of watch out for or what to know about them. And then we'll talk a little bit about the pricing. I'm also going to do that sort of same exercise on a split system, just using the Sanden as an example, and then some of the pricing on that. And then Grant, feel free to jump in if there's questions or comments or anything you think we should address as I go through these slides.
We have a number of questions. I've kind of shot back responses real quick. If anyone wants us to open it up and talk about one of these items that I just responded to, just say so and I'll interrupt Jennifer again because these are good questions, but I don't want to sidetrack us right away.
Okay, appreciate that. Some things to just know, you know, again, speaking from like the perspective of the architect, you're working with your clients, and whether this is a multifamily project and you're doing individual heat pumps, or maybe you've got an ADU where space is tight, or perhaps a single family residence, it's good to understand that these heat pump units are taller than your standard gas or electric unit, because that heat pump is on top of your, 50-gallon or 65-gallon tank. So they are taller. And the sound level is around 50 decibels, although the newer models report 45 decibels, where we keep that in mind because although that's about as noisy as most people's refrigerators, we're finding that folks don't like to hear it near their bedrooms. And you can get some vibration in the system. So we do recommend that you use like flexible PEX piping at the transition from the tank into like your copper piping, especially retrofit, if you have existing copper piping. The other thing to know is that cold dehumidified air is expelled, which if your house is in cooling mode, that's great. You might appreciate it. But if your house is in heating mode, and this is in, say, a closet near your bedroom, and that exhaust air is blowing into the hallway of the house, that may be something you want to talk to your clients about and really think about where you're going to place the units. These units are typically placed in garages. And so that often could take care of all of that. The other thing is when these heat pumps were first coming onto market, the older models needed 1,000 cubic feet of volume of space to not overcool the space, or you need a ducted vent kit. And the current models are all around 700 cubic feet. That's come down. And some of the newest models, like A.O. Smith has one, only needs 450 cubic feet. So the systems have become more efficient over the years. And as such, they don't need quite the air volume of space in order to function properly. And some of the things you still need to worry about is how do you take care of condensate that comes from a heat pump? So like we talked about with the heat pump space heating, same for the space heat, for the water heating. So you need to drain, or you need to plumb that or discharge it either outdoors, or you can put it into a local drain pipe that's part of your sink drainage or your washer drainage. There's different modes of operation on these for higher efficiency, hybrid, air quotes, you know, both heat pump and electric resistance, or you can do electric resistance only. And I've heard anecdotally that people put their system into electric resistance heating only for short periods of time when they know they're having guests come over and they need to have the recovery rate be much quicker than you would get in an efficiency heat pump only mode. You can also dial it down and put it on vacation mode. The other thing to know about these is there is some maintenance, and that maintenance is mostly dealing with the control system and setting the controls the way you want it. But there is also a filter at the top of every one of these units, and that filter is to protect the fan coil on the inside of this unit. The reason I mention this and call it out is I do think the architects, the more I learn about this, I do think it behooves the architects to put a note on their plans to maintain clearance at the top of the heat pump water heaters, because what we've seen is that pipes are plumbed over the top of the unit, and then the homeowner or the business owner isn't able to pull that filter out and clean it. And the filter is a screen mesh. It's easily cleaned. You can rinse it off or vacuum it off or wipe it off, or almost like a lot of the dryer lint vent collectors are on some systems. It's very straightforward. But if the plumber doesn't really realize that and puts the plumbing over the top and you can't access it, then you're not going to get the efficiency and be able to maintain it. This one, it looks like the pipe goes across the top, but it's actually more against the wall, so it just misses it. But that's something to be aware of. Yeah, go ahead, Grant.
I'm sure you're going to touch on footprint and space. We kind of already touched on that volume that it needs to draw from. Code for electric ready, if you're doing a new single family residence and you're not installing a heat pump water heater, you're still required to provide the connections and space for future installation of one of these units. Code says that is a 2.5 by 2.5 foot space. We've seen a lot of people trying to install these in 2x2, and a lot of the times that is what drives that tight plumbing that causes a lack of access. Plumbers I talk to want 3x3, you know, so the minimum that we're supposed to be designing to is 2.5 by 2.5.
Yeah, really good point. This gives you a little bit of an idea of that. I didn't put in that exact slide that Grant was referring to in this slide deck. We do touch on it on our other trainings, but this closet here for a multifamily project is an example of the larger size closet. So the architects, we did work with them, and they worked with their installing contractor, the builder, and so those closets did increase in size a little bit to accommodate the small, pressure tank, and to accommodate the duct system, and to make sure that there was no plumbing going across the top, etc.
Can
And
you
even
go,
if you, oh, go ahead.
can you go back one slide really quick?
Yes.
The one on the left, that is for a office building, People Self-Help Office in San Luis Obispo. So no, that's not a typical residential installation. Sorry, you can keep going now.
Yeah. Oh, but it could be.
It could be. The comment was that there's a lot of spaghetti in the left image.
Oh,
But
yes.
just a little bit more of a complicated install than a typical single family.
That's right. That's
Yeah.
true.
The
Yeah,
unit
it was-
itself could be a residential unit. It's a large
Yes.
one, but it could be.
Yes. Yes.
Thanks.
That's right. And then this would be more typical of what you would see. This is during construction. So they hadn't come back and fully insulated all the piping yet, but they did get the ducts on, and it shows you kind of an idea of the closet size. And there are, there's requirements on the duct kits with each of these. And there's even some folks are adding a damper. If you're in a single family and you want to send that cold air up into your attic, for example, you potentially could do that, or you could send it to the outdoors if you're in heating mode. So there are creative solutions that are being done with the duct kit options. With the split system, the most readily available split system in our area right now is the Sanco 2 unit or Sandon unit. There's a lot of brands available internationally. They have been for years, and they're, hopefully soon they will be available in the US. But right now, this is probably the most common one you'll see, and the most readily available one you'll see. And the beauty of these types of systems is that they can operate in very cold temperatures, including 20 degrees below zero. Whereas the integrated tank type, they do have an upper and lower cutoff limit for low temperature and high temperature. We'll hit on that next. This uses CO2 as the refrigerant, and there's no noise in the indoor tank, so it's very quiet. And the pipes need to be fully insulated from the outdoor unit to the indoor unit, and it can be a really clean, clean install.
We had a quick question, Jennifer.
Yeah.
Going back to the duct kit,
Yes.
when you're sending that cooled air and you're ducting it into the attic, is there concern for condensation?
You would send it into the attic during, well, no, because you'd be sending it into the attic during your air conditioning mode. So the idea, like folks down in Texas are experimenting with this, because really what they're trying to do is use that cool airstream to help push the more moist air and buoyant air, which is the hot air, the more moist, buoyant air up and out through your attic ventilation, and just use some of that air to replace some of it, just to cool the attic off.
Yeah, and
So
what if
you're
the
not
attic
trying to
is
put that
unventilated?
put that into a,
Yeah, and sorry, Jennifer, I'm gonna jump in here. My question is specifically when we use the unventilated attic assembly that's allowed in chapter, it's like 1203 of the building code. A lot of our buildings are moving more toward that just for wildland urban interface concerns.
Mhm.
And so I guess like in that instance, right, the idea is that condensation is happening like within your either your typically we're doing like the prescriptive R value of air impermeable above the sheathing, and so all that moisture would get trapped in the attic space, would have to effectively come out through the ceiling in some way, shape, or form.
Okay, so, okay.
It's very nuanced, I know.
Yeah, it's nuanced, but also you're talking about a situation that would benefit greatly from vapor ports, which is part of the code, and it's works with the wildland interface, and I'll just have to be really disciplined and say, let's see how much time we have if people want to stay on the call afterwards. But
Perfect. Yeah.
also then
Thank you.
just keyword vapor ports, and then get back to us in Code Coach.
Yep.
Kind of, just options, just a reminder that these outdoor units can be mounted high on walls, they can be ground mounted, and they can be roof mounted, and just need to maintain a certain amount of clearance around the spaces for good airflow, just like with the space heating and cooling outdoor condensing units. The split system has some benefits in that you can fit them into tight spaces because they don't have filters and no noise. So you're a little more able to put the plumbing however you want it in order to fit it into those spaces. And then you do have, depending on the depending on the model, depending on what year it came out, you'll need to look at that specifically to figure out what the horizontal maximum distance and the vertical maximum distance is, because those numbers change slightly depending on if it's your, if it's third generation or fourth generation, etc., on the Sandin system. So I would, look that up. But you get pretty good distance allowable, and the efficiency doesn't come down too much when you spread them out. So that's nice. That way you could put the hot water tank where you need it and put it closer to the hot water fixtures rather than having it far away out in your garage, like with the integrated system.
And we've
Some of the
seen
things
higher end
yeah.
custom homes really want to do this to address that noise concern. We mentioned it in the comments earlier, that these integrated units do make more noise than we're accustomed to, various ways to address that. But when you split the unit with one of those Senko units, that tank doesn't make any noise. So that's a benefit.
Right. And then there's a price tag premium that goes with it to be aware of. So when it comes to purchase price and operation on these, split system costs more than the integrated, but also you're going to be oftentimes looking for rebates or tax credits if you're replacing existing systems. The bigger the size, the more capacity, and the higher the efficiency, and the higher the first hour rating, all important for right sizing the system, but the cost goes up as all those things get bigger or faster or improve. And then the other thing you need to know about is some of these integrated units can only go down to 45 degrees Fahrenheit. So that's fine for a lot of our Tri-County regional area, but like in my own case, I haven't replaced on my own home. I have not replaced my existing water heater yet, but it's these cold operating limits in my case where I'm thinking I'm probably gonna be pushed into a Sandin because I don't have a location in my existing home where I could keep the tank at 45 degrees or warmer, So if it does get really cold, then it means it's going to kick into electric resistance mode only. And that doesn't really make sense for me to get an appliance that's going to be operating on electric resistance all the time. So that's something to think about. And then the noise we mentioned, and then believe it or not, the integrated 240 volt units are less expensive than the new plug-in types. And then how far away these systems are from where the hot water is needed can impact the performance. You know, longer lengths makes a difference. And then with the split system, just want to make sure all that piping is insulated, and to really look at all your outdoor mounting options, make sure, you know, if it's up off the ground, keep everything clean, that's great. And then your electrical work needs to be brought in on all of these units. But like Grant alluded to in the new code, if you choose to install a hot water heater that is not a heat pump, then you do need to reserve enough space for one, and you have to provide the kind of electrical ready for that heat pump water heater to be able to go in. And on the retrofits, it's just part of the cost. So before you shop, you gotta figure out what size you will need for the situation. So this is a good resource here. You're going to get a copy of the slides, so you'll be able to, even though it's A.O. Smith, but they do give you some feedback on the size you need. But, you know, brand neutral would be going with the Building America Solution Center, energy.gov, and taking a look at their tool for how to size your heat pump water heater. And then some of the other brands are trying to help folks understand what they need. So for Rheem's plug-in unit, they, you know, are telling you if you have more than a couple of people in the house, you're going to want to go with a larger tank, which anecdotally seems to be true. And then when you start shopping for these, you can go to marketplace.scE or guide.pgne.com to show you what's available and what is linked to which rebates. And that can help you kind of get started. And then from there, you can hone in further and start to look at, say, you're going to go to Ferguson's and look at A.O. Smith and look at this particular line. What you're going to see is the price varies a little bit depending on if you're just going with the baseline model, or if you're going to get 2 of the electric heating elements in there, or, you know, you're going to have it ready for a demand response communication. Like, all of these things affect the price a little bit on each of these. And they typically have a 10-year warranty. And again, the temperature range is 45 degrees Fahrenheit. But the slightly newer models, they're kind of next step up, a little more expensive, but they're going to have a higher efficiency, which is UEF with the heat pump water heaters. Uniform efficiency and leak detection is often part of it, which is super useful. But again, you know, the price goes up a little bit, but not a lot. But that's where you're going to see some of the price difference in these. And then even the newest model now, 450 cubic feet is all that's needed. Still have the leak detection, a lot of the same efficiency, but now the temperature range also gives you a little more flexibility. So this one can go down to 37 degrees Fahrenheit before electric resistant mode kicks in. And then the price goes up by a few $100s for that. And the ducts are both inlet and outlet are now at the top with the easy connection. You still have to make sure you can get to the filter and change it, but they're just trying to make these units much more user-friendly, so to speak. And if you do go with the plug-in, this new plug-in one does use the lower global warming potential refrigerant, which could be important to some folks. And they're going to give you a sizing guide on this. So on the plug-in, you're going to find that your 66-gallon plug-in is only recommended to replace a 30 to 40-gallon gas water heater. So if you already are used to a 50-gallon gas water heater and you want to do the plug-in, you're probably going to go up to your 80-gallon. And so then the price on this is going to go up even more. So you will spend more money on the plug-in version, but theoretically you don't have to bring in an electrician for $1,000 to $1,500 to bring in your electric needs in a retrofit. And this just gives you a little bit idea, same kind of thing. Look for sale pricing. Oops, sorry. Look for sale pricing. And then as the gallon size goes up, you know, the price goes up with it. With the split system, you're talking the price jumping up to 2-3 times, sometimes 4 times as much as what you might spend on the integrated system. However, it might be worth it, or it just might be the best solution for certain situations. Grant was working on a project recently where I think this ended up being just the best solution because they really could not find space for individual integrated heat pump water heaters for this triplex. I think I'm getting the story right, or a 3-unit apartment. So 3 of these tanks, the cost of all that versus they did a central system with this and a larger tank, it ended up pricing out better.
Yeah, that was a retrofit of an existing building into 3 units. So the classic income property renovation, and the real estate to yank away to include what they had proposed of a bunch of the integrated units was not a good idea for the, you know, rental value of the units.
Right. And then we're even seeing situations where, well, yeah, let me just leave it at that. We got to keep going. Depending again, the tank size on these, but the tank size, as you go up in capacity or storage, the price goes up accordingly. But the advantage here is you don't have to deal with typically running electric, and you don't have any noise in their tank, and you've got the really, really low global warming potential. And so, you know, you can, there's a one of the resources I like to use monitors and kind of tracks what the going prices, and they'll interview a lot of people to find out how much they're spending on the installation. And I was kind of surprised, but they were coming up with like $3,600 to $5,000 for installation on the heat pump water. And it depends on the complexity of the job, and the bigger number is definitely for larger houses or complex systems, because you will, and if you're doing large custom homes, you're going to reach a point where should you be doing smaller systems closer to where they want the water, or is it one big system with more complex plumbing needs as you send that hot water to fixtures that are very far away? And depending on the size of the piping, you could potentially delete all your hot water just within the piping of the house if the plumbing design isn't really thought through. And if that's the case, then heat pump water heaters aren't really your friend at that point, because the recovery rate isn't as high as you're going to get with, say, an on-demand gas unit. So in California, we got kind of spoiled forever hot water with these on-demand gas systems. So it's something to think about. So you don't want to skip over that first step of right sizing, but also if you have a complicated house or a very large home that you're working with, you're going to want, I think, some feedback. and some help on the design side of it. There's tax credits available and rebates available. You can get to those through EnergyStar.gov, or at least learn about them through the Inflation Reduction Act. We have 2 programs in California, the home efficiency rebates and the home electrification and appliance rebates. You can find out or link to some of these rebates directly through the Clean Tech California and the Golden State rebates. Both the websites are there. Just a little FYI, the Homes program launches coming up this 2025. It's not quite up and running yet, but the California Energy Commission has seen some fraud around this. So they're cautioning everyone that if they're advertising that they're going to get you some of these programs, be cautious, because they're not fully in place yet, but they will be soon. And then last but not least, a few kind of things for maintaining kind of client expectations, just like with your heat pump for space heating, your heat pumps, if you're split system, keep it away from your dryer vents. You know, don't forget, you do need some periodic cleaning. And if you want, you know, your most efficiency, it's heat pump mode. And just an reminder that the noise and cold air can be problematic for some occupants with the integrated or unitary unit. So you want to design for that. And then when it comes to the architects and understanding kind of our requirements, we do a whole course that deals with the HERS stuff, but I'm going to highlight just a couple of the main things. Is, you know, call out all pipes are insulated if you're taking that credit. And otherwise, the whole system should be straightforward for your HERS rater to verify the equipment itself. If your client wants recirculation, you can, with the new systems, you can do a recirc pump on them. However, they do need to be plumbed properly, and you do get a penalty in your Title 24, but not so much so now that you can do HERS demand recirculation, demand control verified. So I recommend that. And if you know you're going to call out on your plans that all of the pipes are insulated and you're willing to have the HERS person come out there and do that and check for it, you can get credit on your Title 24. And just remember that all the joints and everything needs to be fully insulated and taped. And then we think it's really important that you consider point of use where noise isn't going to be a problem. And the point of use overall, even if you don't take this credit in Title 24, it's good to start to understand that the size of piping that goes to each of your hot water fixtures has a huge impact in the quantity of hot water that is needed for a project. So you want to manifold down right away from your heat pump water heater and send out the smallest lines possible to those fixtures, because otherwise really big pipes hold a lot of your hot water, and you can heat up all the pipes and take all that water from your tank, and it'll just be sitting in those pipes until the next time someone calls for hot water. And meanwhile, now your tank is trying to go through a recovery mode. And if you're going to take these credits, or you know you're going to do heat pump water heater on the project, we're starting to tell the architects to put it right on the front cover. Just really call it out, because we have seen situations where the contractor is, you know, reaching out to us through Code Coach because they're wondering can they change it and not use a heat pump water heater? Why? Because a lot of times maybe it's too far, closet wasn't large enough. They're having a hard time figuring out how they're going to maneuver all those things and get it in, et cetera, et cetera. And Code Coach is where you can reach us to answer all your questions. We have upcoming courses. I'm going to turn this back over to Chloe to close us out. And as long as it's okay with Chloe, Grant and I can be on the line a little longer for questions.
Yeah, that's absolutely okay with me. And thanks for a really terrific presentation, Jennifer. That was great. And yeah, quickly go over a few logistical things and I'll send it back to Jennifer and Grant to answer any questions that you all have. I'll be sending out the ZNC certificates and registering AIA learning units in the next few days. If you have any questions, just a reminder to email me. It's better to get those questions answered earlier than after the fact. And another reminder that we are using attendance records from today's Zoom to distribute these learning units. So if you haven't registered and you're joining with someone else's Zoom account or Zoom link, just make sure you email me so I can make sure to correctly record your attendance. The slides from today's training and the Zoom recording are going to be sent to your email in the next few days, as well as a brief survey. If you guys can take that, it really helps us out to improve these trainings and provide the sort of trainings that would be helpful for you all. And then lastly, we have several upcoming courses that you guys might be interested in joining, including parts 4 and 5 of the All Electric Design and Construction series in the next 2 Thursdays. We also have a green building tour in San Luis on February 11th. And you can sign up for these trainings and also see more being offered on our website. And that's all for me, so I'll hand it back to Jennifer and Grant.
We had one question I didn't have too good of an answer on, Jennifer. I thought maybe you have an idea. Joanna was wondering how far, say, a split system or equipment that's roof mounted should be located away from commercial kitchen exhaust. So she's concerned about grease-laden winds. I don't have any, like, I would imagine this is a mechanical code item. I don't have anything off the top of my head that like a rule of thumb distance from commercial kitchen exhaust to any roof mounted mechanical equipment. I would imagine it's just the same if there is one. I know you have that item that it's like 5 feet from dryer vents. That's for the intake of a heat pump water heater if you're doing one of those duct kits. I would imagine it's more than that. Have you heard of anything in that realm?
10 feet is the number that pops into my mind, but I can't remember if that was rule of thumb or a mechanical code specific. But that's a great question. What for the few that we've done that had the commercial kitchen part of it, the architect, the mechanical engineer, like some of our multifamily, I mean, they did the heat pump water heater, they did it in a right off the kitchen in a protected separate patio area with high wall, just for part of their maintenance. And then they did everything through the roof, and then the rest of the hot water and heating cooling systems was positioned at least 10 feet away. I think it was closer to 20. And then I'm thinking of the big one too we did in San Jose. It was at least 20 feet away from all the intake.
I have seen on those bigger projects a lot of mechanical wells or some type of stem wall protecting the units in general. I've also been on Firestone's roof a number of times, and I know that it can cause a lot of problems. Yeah, if they're in close proximity, it turns into a lot of mechanical replacements and failures. Or just cleaning.
Yeah, right. So good question. I know that's, yeah. I mean, yeah, they should be separated because the fine fins on those fan coils for both the heat pumps and your hot water heaters, no, you don't want to clog them up and have them get greased up and then have other debris stick to them. The performance will go down immensely. So, yeah.
If anyone has other questions, send them in. We had a number of good ones in here, Jennifer. Recovery efficiency. We had a floodplain question.
Oh, nice.
I haven't run into any floodplain concerns specific to these, types of units. They treat them the same as other outdoor condensers, so I haven't seen anything specific to water heaters.
Right. Yeah. I haven't seen anything specific to water heaters, but like, the monoblock systems. I did notice that almost every one of those manufacturers offers like mounting racks to get them up off the ground, not necessarily wall mounted, but still, both for snow, but water and
Yeah.
inclemental weather. So places that have, that are used to like 4 seasons, definitely they're being positioned where they're protected from the elements. Some of the situations where you might have rain or more snowfall, they do give clearances for what you can have for, it's usually 5 feet above the units before you have an overhang for protection from both rain and snow. And you want to put them where you're not going to collect up debris, outdoor debris. So in wind, you don't want a wind eddy effect. So you need to think about it, but all our heat pumps were like that anyway. And air conditioners are heat pumps that just don't provide the heating. And those also had the same requirements, and same with all our rooftop units for commercial. So in a lot of ways, it's those same requirements, same basic ideas for maintenance and location. And just now with our better refrigerants and inverter technology and the way we're able to, the way these systems are designed to micromanage essentially the refrigerant quantities, they have just much higher efficiencies and able to do heating and cooling effectively. So that's why they're being promoted now as viable ways of moving California towards all electric as our grid gets cleaner. Plus, we just don't want to use as much electricity in the first place.
Right.
But some of these requirements and distances from venting and maintenance, that same maintenance should have been being done on all the equipment already, no matter what the fuel source was. It's just that a lot of homeowners just don't do it.
Yeah. And then we
so
had
you'll notice the efficiency really drop if you don't do it.
Right. Yeah. We had a good back and forth a little bit about operational costs. Elijah, if you want to talk more about that, just let me know. Shoot me an email. Everyone's seeing the utility rates factoring in more so.
Yes.
These units they're not being touted as cheaper electricity bills or cheaper water heating bills necessarily at this point, but that's not really a factor of the units themselves.
Right. So if you have an existing electric tank, which
Yes.
we do in California in some locations, and you're able to go to a heat pump tank and you're able to operate it in heat pump mode, then you're going to see a big reduction in your electric bill. But if you're comparing it to an on-demand gas unit, which is pretty popular in California for a lot of existing homes, and compare that to a heat pump tank, for a while, the pricing on gas and electricity was such that maybe at the end of the year, you might be $30 to $50 more on your heat pump. So, but for a lot of people who could afford the whole project, it's like, okay, it's a little maybe more expensive, but then a lot of times it's a lot of our same clients that are getting PV systems installed.
Right.
And so then it becomes kind of a, you know, then that doesn't matter again so much. It's more of the big picture of what they want to do for their heating, cooling, you know, architects who want to do this themselves so they know what it's like, so they can talk to their clients about it. And then for our multifamily projects, for those projects that are looking for incentives, then there's great incentive to go heat pump water heaters, plus they're doing PV installations as part of their funding pathway. So again, it's kind of rolled all into an all electric approach and reducing their carbon footprint in general. So the kind of the tricky part is if you have existing homes and you want to replace it with a heat pump water heater, the operational costs may factor in, but maybe not. But that's where most of the rebates and incentives lie, is for actually replacing a tank type gas unit and a tank type electric unit. That's where the incentives come in and the cost savings come in.
Thanks. I'm not seeing anything else, so unless someone chimes in at the 11th hour, I think we're good.
Okay, I want to thank everybody who hung through those questions, and I hope you all have a nice day, and we'll look forward to doing the 4th course coming up.
Thanks. I'll end the recording here.
Right.